Now here we have a problem. In this problem we have to find out the maximum power. I will once read out the problem. The photovoltaic cell has an open circuit voltage of 0.6 volts and a short circuit current of 250 amps per meter square, and the cell temperature is 40 degrees centigrade. Calculate the voltage and current density that maximizes the power of the cell. What would be the corresponding maximum power per unit cell area? So they have given data: open circuit voltage, cell temperature, then short circuit current. So the data given are this one is VOC voltage, short circuit current ISC, then temperature in Kelvin 0.6, 250, and this is 40 degree. But we have to change this 40 degrees. Next, to find out PM, maximum power, we should analyze what are the data given. So if we recall this curve, this is ISC and this is VOC, and somewhere here we will have PM. So to find PM we need ISC and VOC. So we have to find out PM. We'll substitute that so now I'll give the equations which are required to find out PM. The first one is we should find out voltage, then we need to find current, then we can get the PM. After substituting these values in the equation we'll get the PM equation. So the voltage, maximum voltage, VM, this is VM, this is IM. To get VM, so this is one equation to get VM, where VM you can get by trial and error method. So we'll get an equation with VM and we have to substitute some random numbers and find out the VM using trial and error method. Then for current we have IM is equal to EVM by KT divided by 1 plus EVM by KT into ISC plus I naught. Using these equations we will obtain PM equation. This derivation we have discussed, so I'm not going much depth only for this derivation. There are videos uploaded regarding this derivation in the previous session, so you can refer how substitution is done. So now to substitute in all these equation, we need ISC by I naught, then we need I naught by AC, and then we can substitute in the equation, then we can get the PM. So very first we need ISC by I naught. So ISC by I naught, so we see here the relation between I and V. This is a current and voltage that passes through the solar cell circuit. From this, for open circuit VOC, I is equal to 0 because it's a open circuit. Then we can get equation ISC by I naught, ISC by I naught is equal to exponential OC VOC by KT minus 1. This is same expression what we see here. Then from this we will substitute the values. Exponential of, these are constant, 1.602 into 10 power minus 19, then 1.381 into 10 power minus 23, into VOC we will substitute 0.6313 in terms of Kelvin. Temperature I am substituting in Kelvin. Minus 1 we will get 4.544 into 10 power 9. So this is ISC by I naught. This is ISC by I naught. This we need to substitute in VM equation, and we'll find out also reverse saturation current density, saturation current density, so this is 5.502 into 10 power minus 8 amps per meter square. So we can cross verify the calculations. These we have calculated already, and now we'll take the equation for VM. One plus 1.602 into 10 power minus 19 VM divided by exponential of, this is the equation which is already discussed, so I am just substituting the values. This is a equation for VM. To get PM maximum power we need VM. This is equation for VM. or it can be written as 1 plus 37.062 Vm exponential 37.062 Vm to 10 power 9. So now we have a variable in two locations. Applying standard trial and error method, I request you to find it out, and the answer I will give you, it is 0.519. So now we got Vm. This is first thing what we wanted. Then second thing is Im. We have to find Im. So to find Im, the equation is again shared already. So I will calculate directly Im by A. So for the previous equation which I have already given, I have substituted the values. Still the last part is remaining, 250 plus 5.502 into 10 power minus 8. So Im is equal to 2.37 237.6 amps per meter square. So we have substituted in this equation for Im for unit area A, and also before that we have substituted in Vm equation. This is equation for Vm Im, and hence Pm. Therefore Pm is equal to Im into VOC So this is all about how to find Pm. So here you see P is equal to I into V. We have I here, we have V here. I into V is equal to power. So this is how we will get the maximum power obtained for a given current and voltage values.